Welcome to qnawire.
So we know that external torque is change in angular momentum over change in time. And if there is no external torque applied, then change in angular momentum is zero, or we can say the initial angular momentum is equal to final angular momentum, or simply the angular momentum is constant. So in this case, since there is no external torque applied to the skater, the angular momentum of the skater is constant. And we know that angular momentum is given by I times omega. So Li will be initial moment of inertia times initial angular velocity, and we do the same for the final part. This gives an expression for the final moment of inertia, which is initial moment of inertia times omega I over omega f. Now we are already given the values of these parameters, so we use that over here. So initial moment of inertia is 4.6 kg meter square. Omega I is one revolution in 1.5 seconds, and final angular velocity is 2.5 revolution per second. Since we have a ratio of the angular velocities over here, we don't need to convert omega into units of radians per second, since ultimately these revolutions, the units cancel out. So we solve it now, and we get IF to be 1.2 kg meter square. Now, so she accomplishes this by starting with her arms extended. So that corresponds to the initial angular velocity, and then pulling her arms into the center of her body, which gives the final angular velocity.